Hey there! We will be taking this vector class that I had put together last time. I had turned it into a template, and I'm going to be splitting it up into a header file and an implementation file. This is typically good style in C++. We like having files that have very specific purposes, and that helps us organize things a lot better. So in Visual Studio, I'm in my custom vector project where I had left off, and you can see that I've demonstrated creating one of these vector objects. This one stores integers and this one stores strings. And I'm including the vector.h header file. This is how I want my program to work. I don't want to change anything about this. I want to change this header file a little bit. What I'd like to be looking at here is, instead of just a bunch of function implementations that I have to scroll all the way down for, I kind of want this summarized for me. I don't care when I'm just looking at this as like a sort of reference. I don't care about how the function actually works. I care that the function exists, and I care about what input it needs and what output it gives me. So I would love it if, instead of seeing all of this, I just saw the declarations of these functions. Now this is normal for a regular class to move these into another file. So I'm going to do that and show how that works. So let's see, I'll add a new item. I'm going to name it after the class vector.cpp. Okay. So first up, I'm going to include my vector.h, and then I'm going to go to vector.h, and I'm going to move all of these. I'm going to copy all of these function implementations. There we go. So now I've got some errors because the compiler doesn't know where this function is coming from. So I need to tell it which class it's coming from. This would be what I do with a normal class, but with a template, this is not fully specifying what class there is. You remember the class has a type parameter too, like this. But then in C++, this is still not enough because now it doesn't know what t is. I need to specify that as a template parameter. Type name t. There we go. So now it recognizes this as something valid. I kind of have to do the same thing for all of these other functions. So the constructors are fine, just put this in front. The other ones, this needs to go as part of the name, as part of the identifier, in order to identify this function. Alright, I have a lot of these functions that return void, so I could just replace this part of them. Alright, that one's returns an int, and this one returns a t. Okay, t. There we go. Alright, so I now have all of these functions implemented in a separate file. So I don't want them in this file anymore because they'd be duplicates. But I still have to declare them. I have to say that these functions exist, and the implementations will be found elsewhere. So I just have to declare them. Okay, so I left the declarations here. Alright, everything looks good. So with a normal class, this is all I have to do. However, with a template, there's a little bit of a problem. So I'm getting a bunch of unresolved symbol errors. This is saying that the implementation to these functions don't exist. So this one looks pretty complex. Public, this call is a decorator. We don't need to care about that. Vector for integers. Vector for integers, this is the default constructor. There's no arguments, and it's called vector. It is unresolved. It's referenced in my main function, but it doesn't know what it's referencing. There's no real implementation for it, and the same for all of these other functions. So what that's saying is that it is not actually locating the definitions, the implementation for those functions. This would normally be done by having vector.cpp. You can see it in my project panel over here, my solution explorer. It's in my project, so it's going to get compiled and linked in. However, this is the key. Templates are not classes. They are template classes. They're instructions for how the compiler could generate a class. But in this file, there's nothing telling it to actually generate a vector class of any type. No vector of ints, no vector of strings, or anything in this file, so it doesn't get generated. When you're looking at the main.cpp file, this other compilation unit, this tells it to create those things. Vector of ints, vector of strings, but what the compiler has seen so far in this file is only vector.h. Vector.h just has the declarations, has no implementations. So this is where that ideal of splitting apart definitions and implementations kind of falls apart for templates. So we sort of have to figure out another way around in order to make sure that all of these definitions are still seen by the compiler in every compilation unit where vector.h is included. So that means I have to include that implementation file. So what I could do in vector.h, I could at the bottom say include vector.cpp, and then magically, using the preprocessor here, it has done its copy and paste job of taking all of that code and just slapping it down here in the header, and then every compilation unit is going to see it. Now this should only be done for templates, including a source file like this. And it's kind of confusing because this is ending with a .cpp abbreviation or file extension, and it's showing up in my project as a file that's going to get compiled, and that doesn't really need to happen. So one method that can kind of make this a little nicer and also at the same time a little not nice because of a couple of issues with Visual Studio is to rename this now, because it's not going to be a normal source file, so it should not be compiled, and Visual Studio will automatically compile any .cpp files. I just want to rename it. I've renamed it to .inl, like inline, so that all of this code is going to go inline in with my header file. So now that's the file I want to include, and that should make it work. Let me build this. Okay, let's see. Function template has already been defined. So here's one of those kind of bugs popping up. This one's actually fine, but in a header file, what you'll often see is this pragma once at the top, and that makes sure that the header file only gets included at most once. So so you don't get multiple copies of this template or whatever other definitions you have in your header file. We don't have that in here, but even if I put it, assuming that bug is still here, let's see, pragma once. Yeah, so it still does not work for this. There's an old way that we used to use include guards in order to protect a file from getting included multiple times. So I'm going to have to do that. Let's see. So if def, and then let me make up some symbol, vector, I'll name it after the name of the file just to keep it clear. Alright, so using the preprocessor, I'm going to check to see if this symbol is defined. If it is not, so if not defined, if ndef, this symbol. Then we define it, and we go through the whole file, and then at the end, pound end if. All right, so end that preprocessor if statement. So if this is defined, it will skip all of this. It'll skip all of this if part. So because I'm checking for it to not be defined and then I'm defining it, the next time around it's going to be defined and it'll skip the whole file. This is the old way we had to do it, and it takes a few more steps just to make that work. So that compiles, succeeds, can run it. Looks like it works correctly. This is just one of those annoying facts of living with templates if you want to split up the code like that. When you're using a template, it's really up to you whether you split it into an INL file or just put everything in the header file. That's fine too. I prefer it this way. There's another bug with this. Sometimes you'll lose IntelliSense in this file because it doesn't treat .inl files as proper C++ files, though it should. So that's kind of all of it. All those fun details of working with templates. If you want to maintain this nice style of separating the interface from the implementation. All right, I will see you in the next video.